I was hoping we could take a quiz at the beginning of class.
Yes, we will. Oh, okay. I'm just going over questions. No, first. So you guys, in English, if a 500-pound load is suspended by two chains, what is the magnitude of the force each chain must be able to withstand? Or in other words, what's the tension on each of those two chains? So basically, in red, I'm really looking for, shoot, I can't finish my sentence. I know I just read the question. I just lost track of the choice of words.
Magnitude of each of the vectors.
Okay, so this isn't a big question. It's smaller than I thought. He's not asking for these force vectors. He's only asking for the magnitudes, nothing more. Oh, by the way, because it's a 500-pound load, would you guys not agree in blue? I can represent that as a vector. But I have to confess, it's going in a downward direction because gravity is pulling in a downward direction. Now, I maintain if this system is going to be in equilibrium, then the sum of those three vectors is going to be zero. Or maybe you don't look at it that way. Maybe say the red one's added together is going to give you the opposite of the blue one. That's fine. Well, if you've got some background in physics and you write it that way, I feel more comfortable with it as well. Sorry, guys. Let me take a brief moment. That being the case, oh, guys, if that is the case, I'm running out of. I need to be able to write this. So can I just introduce notation? Can I call this V1 bar?
Sure.
Do you mind if I call this one V1 bar 2 because they have the same magnitude?
The same output, not the same direction.
Good. I can't call it V1 bar. Yeah, they may have the same magnitude. They may have the same magnitude. They do. But since they're going in different directions, I'll give them a different name. What about this one down here? What do you want to call this one?
Let's call it V3.
But if it's V3, can you give me its coordinates?
0, 0, and then it goes down the negative j half.
Oh, or in other words, negative 500 j bar. That's fine too. I was just using different notation. By the way, when it comes to V2 bar, can you do the same thing up here? Can you give me its components? Magnitude of V2 bar, and then the cosine of 45 degrees, comma.
Magnitude of V bar is sine 45 degrees.
Or if you guys prefer. I said, if you guys prefer. Thank you. So, actually, root 2 over 2, isn't it? Times not that, but the magnitude. Same thing. Do you guys agree? Same thing with V1 bar. It's just out the magnitude of V1 bar instead of V2 bar, but same coefficients. And if it really is the case that V1 bar plus V2 bar is indeed equal to V3 bar, then I guess, technically speaking, that implies, okay, I've got my glasses off. I think they were root 2 over 2. V1 bar's magnitude. Plus root 2 over 2. V2's magnitude, comma. Same darn thing for the y coordinate. I forgot my root 2 over 2. And I think this vector is going to be nothing more than this vector over here. Do you guys agree? Did I skip too many steps?
Yeah, the x components will be equal to 0, and the y components will be equal to negative.
Well, true. That's going to be my next step, because if two vectors are equal to each other, it means component-wise they're equal as well. But it's okay that I skipped a few steps.
It's
So your x component of V1 bar is a negative?
yeah.
My apologies. I agree completely. That really was my mistake. Technically speaking, I didn't write V1 bar down, but technically speaking, the coordinates really are those over there, but isn't the x component negative? And I failed to put that in. I completely overlooked it. I'll fix it.
Also, for the top, one of those two sides should be negative, I believe.
You know, I agree that if I put everything on one side, equivalently I could rewrite it this way. that V1 bar plus V2 bar is really subtracting V3 bar from it in order to come up with a zero vector. Now that's true. That's true. You don't like that.
No.
How about saying it this way in English? I think the way I wrote things is correct only because this object that's hanging is not actually moving. And so as a system, I think everything is in equilibrium. The system itself is in equilibrium. And so that's why I maintain the way I have the vectors written or drawn with the colors, I do think that some of those are going to be equals. Aaron?
Nope, I was gonna ask a question and I read your problem and you got it right.
Next, as somebody suggested, I better equate components. In other words, I think negative root 2 over 2 times this, plus root 2 over 2 times this. By the way, what you see above my squiggly line is merely the first component. Has got to be equal to the first component of the second vector over there, which is just 0. Likewise, I will equate second components, that would be a positive root 2 over 2 stuff, plus positive root 2 over 2 stuff, is equal to my, I think, negative 500. Oh shoot, you guys, look what I just did. I created 2 equations and 2 unknowns. They're linear equations, so this is no exaggeration. This really is just a math D question, isn't it? Happy?
Quickly find the magnitude.
So in solving the system, I'll
Okay.
solve for the magnitude of V1 bar and V2 bar.
Okay.
Those are the magnitudes.
Okay.
Everybody else okay with this? Please attack me, that's why I'm here.
So you basically just use like a substitution or something at this point in order to find the magnitudes?
Yeah, you could. I'd be so lazy.
Okay.
Only because these coefficients are equal to each
Are
other.
equal to
by
one another,
magnitudes, I
you
would
could just do
add together.
addition? All
And
right.
I simply immediately get this. That's what I would do.
Okay.
Makes sense?
Yeah.
Now, since we know the magnitudes are the same,
That's a root 2,
is there a
right?
way we can just substitute something else in?
Substitute something else in.
Like, just say that the magnitude of V1 bar is equal to the magnitude of V2 bar, and then just...
You just end up backwards already. Pretty much.
You know, you could, absolutely. In this example, you could. The example I gave you last time, you would.
Yeah. Mhm. Okay.
Yes, Catherine?
Are you saying you're getting a negative value for your magnitude?
I'm getting a, oh, you're right, I am.
I think your original, I think it's going to add up to the opposite of V3 bar, not.
What did I just do?
So
The
V1
sign.
bar plus V2 bar add up to the opposite.
My apologies, you guys. I agree completely. I think when I add these together and get a negative, that sign should change. You're right. Yeah, so what should I change up here?
Negative V2 bar.
So this right here. Everybody there? My apologies. That means somebody was saying I got it. I'm so sorry. This is my second error today, isn't it? That's going to change other things. That means this becomes positive. And you know what, Catherine? I wasn't even looking at that. At a glance, you should have yelled at me saying, well, that means your magnitude is going to be negative. Not possible. So I really did mean to change the sign. I didn't mean to make a mistake. It really was a mistake. Anything else before I get rid of that? Yes?
It's equal to 0 because it's standing still, right?
No, I think this component right here is 0, only because when it comes to this vector, if I were to, with my green pen, draw a Cartesian coordinate system, x-axis, y-axis, notice how the blue vector has no horizontal component. And because it has no...
Well, where you add the 3 vectors.
So you mean this one here?
Yeah. Is that because it's equilibrium? Is that what
Yeah.
you're opposite?
How about if I say it this way in English? Only because this object's not moving. I might say in English that the system is in equilibrium, but in terms of mathematics, what it really means is that the sum of the vectors is equal to 0. So why don't you just treat that as a definition? That's what it means to be in equilibrium for a system. The sum of the vectors is 0. Even though when I wrote it initially, I had a negative sign in there. Yes?
That negative 500 is bugging me because I think like when you move it over, like it should be positive 500. Because if you have the sum of the forces equals 0, and then have that on the other side.
See, I disagree, because I think the opposite of negative 500 on the other side is going to be positive 500. So I think when I put it over here with a negative sign, when I put it in afterwards, after I made a mistake, that forces that to be positive. And that's why this ended up being positive down here. But again, you guys, this might be awkward for you. If you don't like saying, oh, things are in equilibrium when the sum is equal to the zero vector, just give it up and add the vectors together. It means the same thing. It really does. If I didn't butcher that too much, Bradley, is that okay for that one?
Yeah, that's great, actually.
And actually, if you guys don't mind, can I save a little time on the clock? Because I think when it comes to example number 73, I shouldn't talk so fast. I need to slow down and read it. Number 73, Jack pulls east on a rope, attached to a camel with a net force of 40 pounds. Jill does something similar. What is the magnitude and direction of the force on the camel? Assume the vectors lie on a horizontal plane. Is that the same idea, though? I'm just really looking at a system, just like
Yeah.
the one I have up here. And you're going to play exactly.
It's just upside down, yeah. Okay.
Instead of solving for the magnitude of the vectors, you're solving for the resultant force.
In the long run, yes, because the question really is what's the magnitude and direction of those vectors. So for example, in this particular one of the ink courses, I've already got it wrong. I might describe the direction of these vectors just by listing the vectors. This may not be a good example because technically speaking, I know what the angles are. But if I didn't, I could have played that game. You guys ready to show me? No, I'm so sorry, sir. Caleb.
I know you're trying to save time, but I don't understand 63.
So 63. Oh, the U and V bars are given upstairs. Got it. No, number 63 is distinctly different. Let's take a peek at it. I lost it. It's 1, 1, and they have a V bar being equal to negative 1, 1. And number 3 asked me to ask for an arbitrary vector. Can we express it as a linear combination of U bar and V bar? Jeepers, you guys. How do I start off with this?
A linear combination of the U bar and V bar, what does that?
Yeah, that's why I'm saying, that's why I'm stalling. Because when I talk about creating a linear combination of two other items, whether they're vectors, numbers, or who cares what I'm really saying is that with what I have to start with, the A comma B, can I express that as some constant times my U bar plus some constant times my V bar? It sounds like a silly, ridiculous, useless question, and it is everything but. It's an extremely important question. You and I are going to be diving into extensively next semester if you take Math 33. Because it's the case that I even want to talk about solutions to certain kinds of equations that can be expressed in linear combinations of other solutions, and it's a way for me to generate all possible solutions to certain types of equations, namely differential equations. So the whole concept of linear combinations is fundamentally important for more advanced mathematics. Let's give this practice. I think in this example, just writing out what I just said out loud in English, simply says this. It means the following. That my A comma B vector can be expressed as some constant, call it C1 times U bar, plus C2 times my V bar. Or shall I say, A comma B can be expressed as C1 times, can you guys help me with this? Was it 1, 1? And was it negative 1, 1?
Yeah.
For the other. Now, if I were to combine those two vectors by addition on the right-hand side of the equal sign, I suppose it simply means this. Let's see, how do I multiply scalars to vectors? That's yeah, it's component-wise multiplication. That necessarily implies that A comma B, as a vector, is equal to this vector over here.
Your monitor's being turned off.
Oh, thank you. And you guys, I'm stuck. I really am. I actually forget what the question's really asking. What number is this?
63.
63. For arbitrary real numbers A and B, express A comma B as a linear combination. I guess we're done. That was silly. Can I ask a better question?
Sure.
What are the values for C1 and C2? Actually, I thought that's what the question was.
I think that was the answer in the back of the book.
What's that?
They actually have you solve for the values of C1 and C2.
Do they really? I don't know why, that's not really the question. But it certainly was what I would have asked if I typed the question. So you guys, let's answer my question, which is, can we find C1 and C2 in terms of A and B? Well, can we? Well, yeah, because if we treat A and B as constants, and I'm trying to solve for C1 and C2, when I equate these components, I'm building yet again 2 equations and 2 unknowns, just like my last example from the homework. In other words, what I'm really suggesting is this. The component, excuse me, the first component you see on the right-hand side, this one right here, is equal to the first component you see on the left-hand side. And certainly the second component you see on the right-hand side of my equal sign, that's this, is equal to the second component of the vector you see on the left-hand side. And again, treating A and B as constants, I can solve for both of those. Actually, let me just do one real quick. Adding these two equations together, doesn't that give me this? So C1 is nothing more than the arithmetic mean of A and B. And you can go back substitute for good. Make sense? And again, I kind of disagree then with the answer in the back of the book. I don't really think it's what he asked. You guys, anything else from our very first homework set that you want to ask? All right. If not, can you guys put everything in the what?